Okay, is the screen visible?
Yes, sir.
Okay, so what we discussed last time, yesterday what we discussed, if f is a function from set x to set y and g is a function in opposite direction, right? So x, y, f is a function from x to y and g is a function from y to x. If f composite g is identity function, then f is 1 1 and g is on 2, right? And I ask you to find an example where g composite f is identity, but then no doubt f is 1 1 and g is on 2, but f is not necessarily on 2 and g is not necessarily 1 1. And can you find such functions? Did you find such example? Anybody? Yes. Did anybody try to find the example, or nobody tried? Because it means you didn't look at what we discussed in the lecture. So you are not sincerely doing the things which we discuss every day, right? It suggests that you are not sincerely studying the things, right? Suppose I define a function. uh, if I define function f from natural numbers to integers, f of x is equal to x as it is, or minus x, no problem, right? F of x is equal to x or minus x. And I will define g from integers to natural numbers. So this is my set x, this is y. Now f is function from x to y. Now g is a function from y to x. And what function I am going to define? Okay, so integers minus 0. I am removing 0 from integers. And so y is integers minus 0, so non-zero integers. To n, g of y is equal to absolute value of y. Do you understand the functions now? What is z minus 0? Set of non-zero integers. Correct? Set of non-zero integers. So what is this set? All integers. All integers except 0. 0 is removed. This is z minus 0. So I am defining a function from natural numbers to z minus 0. F of x is equal to x. And what is my function gx? G is a function from y to x and absolute value. I am defining it by absolute value. Now do you understand what type of functions are this? 1, 2, 3 and so on, natural numbers. And what is second set? Second set is so what is x? Set x is set of natural numbers. And what is this set? 1, 2, 3 and so on. What is y? Non-zero integers. And what is this set? Negative integers. Then positive integers, right? Again, I write x here. That is 1, 2, 3, and so on. Okay, what is the function f? F is a function from natural numbers to non-zero integers. And what is the function where 1 will go? What is the image of 1 under f? What is the image of 1 under f?
1.
1. Right. So you understand ki f of x is equal to x. So 1 goes to 1, 2 goes to 2, 3 goes to 3, 4 goes to 4. Right. So this function is not onto. Right. F is not onto. Is it clear?
Yes, sir.
Now I am defining g from y to x. G is from y to x. Now what is the image of minus 1?
1.
Image of minus 1, right? Because g of y is absolute 1. And what is the image of 1?
1. 1.
1. So what is the image of 2?
2.
And image of minus 2 is also 2. Correct?
Yes.
Yes, sir.
So image of 3 and minus 3 is same. Image of 4 and minus 4 is same. So this is how we define the functions. Okay, now observe. So then what are the points? F is 1, 1. Is it correct?
Yes.
Is F 1, 2?
No.
F is
No,
not
sir.
on 2. Fine. Second point. G is on 2. Is it correct?
Yes.
Yes.
And is G 1, 1?
No.
No.
1, 1. G is not 1, 1 because we see that distinct points are mapped to same point, 1 and minus 1. So G is not 1, 1. So third point, what is G composite F? G composite F is from which set to which set? G composite F. First we apply F
Natural number to natural number.
natural numbers to
Into it.
natural numbers. Right? What is G composite F of 1? G of F1. But F of 1 is 1 and G of 1 is 1.
1.
Correct? So in general, G composite of 2. G composite F of 2 is
2.
2. Now is it true that G composite F of x is x for all x in the domain of this?
Yes, sir.
Right?
Yes, sir.
From this figure you can observe 1 goes to 1 and by G 1 goes to 1. 2 goes to 2 and by G 2 goes to 2. So therefore what is the observation? G composite F is identity. On N, which is our first set X. Correct? So G composite F is identity. And it is clear that it is clear that F is 1, 1 and G is on 2 because no choice. By theorem we have proved that if G composite F is identity, then F must be 1, 1, G is on 2, which is true in this case. But F is not on 2 and G is not 1, 1. That is also happening here. But F is not on 2 and G is not 1, 1. So is it clear?
Yes, sir.
Right. So because what our theorem says, previous theorem, if G composite F is identity, then first function is 1, 1, second is on 2. First function may not be on 2 and second function may not be 1, 1. Maybe, may not be. Right. And this is example for which first function may not be onto and second function may not be 1, 1. You can find some different examples. You can find many such examples. So I have given you one example. Right. Now I want to define something inverse. So suppose f is a function from a to b, and inverse function of f is a function g from b to a such that so inverse function from b to a is a function such that f of if for x in a, f of x is equal to y in b, then g of y is equal to x. Right, so is definition clear? Is definition clear? What is the inverse function of f? So this is set A, this is set B, and this is f. Now inverse function is from B to A. So if I choose element here, then its image is here in B. So y, which is image of x. Now if I apply g on, right, if you apply g on y, then I should get x is equal to g of y. So if you apply g on y, so basically f sends x to y, right? F sends x to y and g sends y back to x. G sends y to x and f sends x to y. So this is how the inverse function means. For example, uh, define f from x, f from r to r, f of x is equal to 2x plus 3. Okay, is it a bijective function? Is it?
Yes.
Yes, this is a bijective function and you can check this. Okay, now what is inverse function? What is the inverse
क्या अच्छा
function of f? What is inverse function of f? What is inverse function of f? So how to find inverse function for x in domain of f? F of x is equal to 2x plus 3, which is y, right? Right. If g is inverse of f, then g of y should be what? X.
Y minus 3 by 2.
Right. So g of y should be x, and therefore, what is the definition of inverse function g in this case? So g of y is equal to x means what? So what we want, so what is g of y?
Y minus 3 by 2.
Y minus 3 by 2 g of y, because if we apply g on y, so therefore now what is our y? Y is equal to f of x is 2x plus 3. Then what is g of y? That means what is g of 2x plus 3? By definition of g, what is it? Y minus 3 by 2. Y is now 2x plus 3 minus 3 divided by 2. Right? So this is y. And we are applying g on y. But g of y is y minus 3 by 2. So y minus 3 by 2. So 3 cancels, 2 cancels x. So if you apply g on any y, then it gives us back x. For example, if x is equal to 3, then what is f of 3? What is f of 3? 2 into 3 plus 3, 6 plus 3, 9. And now what is g of 9? If you apply g on this 9, which is y now, right?
3.
So what is, right? So 9 minus 3 by 2. So 9 minus 3 by 6 by 2, which is 3. We get back x. Correct? So therefore, what actually happening by inverse function? Ki if inverse x send x, f send x to y, then inverse function sends y back to x. Correct? So if f is from a to b, then inverse function of f is denoted by f inverse. So this is a notation for inverse function of f. And inverse function is from, what is the domain of for inverse function?
B.
B. And it is from B to A. Right? Therefore, if f inverse is inverse function of f, then for x in A, if f of x is equal to y, then f inverse of y is x. F inverse of y is x. But in general, is it true? Ki f inverse y is x in general, is it true? For example, okay, for example, if I define function from R to this 0 to infinity, f of x is equal to x square, right? F of x is equal to x square. Now, what is f of 1? What is f of 1?
1.
1. And now, what is the inverse function f inverse? Can I say that f of 1 is 1? Is it true?
Yes.
Is it true? You observe that f of minus 1 is also 1. Then what are the choices for f inverse?
1 and minus 1.
But
Yes.
is it possible to have two images for same point in case of function?
No, sir.
Right? And therefore, in this case, F inverse is not well-defined function because there are two possible choices. And what is the problem with this function? Right? So cannot be defined inverse function from F inverse of 0, 0 infinity to R. Right? So cannot be defined inverse function from this B to A. What is the problem here? If you choose one, for
It's not
example,
1, 1.
so problem is F is not 1, 1, right? Because what is the problem? Because there are two distinct elements in domain of F which have same image, and if you try to define inverse function, then there is a problem. What should be the preimage? What should be the definition of inverse function? Right? And therefore, since this function is not 1, 1, there is a problem. But when I say ki F inverse function exists, right now here I am assuming ki inverse function exists. In that case, there is only one choice. For inverse, for y, there is only one choice, which is x. So when it is possible, right? So therefore, now we want to observe something new, right? So f of x is equal to x square from r to 0 infinity. We cannot define inverse function because f is not 1, 1. That was a problem, correct? Okay, let me discuss another example because this is very essential to understand when we define inverse function. Okay, this is first. Second, if I define f from R to R, f of x is equal to x squared, right? Fine. F of x is equal to not x squared, what I should say, e raised to x, for example, because I want to have some different idea. E raised to x. Okay. Is f11? Is this function 1, 1?
Yes, sir.
Yes, sir.
Yes, right? Because exponential function is like this. And clearly it is 1, 1 because distinct points. So S, this function is 1, 1. So 1, 1 S is not an issue. Now, my second question is, can we define F inverse from codomain R to R because codomain is R? For example, what is F inverse of -2? What is F inverse of -2? Go back to the definition. If f of x is equal to y, then f inverse of y is equal to x. That means if you want to define inverse function, y should be image of some element in domain. Do you understand? It's clear. If you want to define f inverse of y, y must be image of some element under f. Is -2 image of any element under f? Is it correct?
No, sir.
Not possible. Why? Why? F inverse of 2 is not possible. Why not possible? We cannot define inverse because
-2 does not belongs to codomain of F.
So there does not exist x in R such that f of x is equal to -2. If there is some x in a domain of f so that f of x equal to -2, then we would have f inverse of -2 is equal to x. But this is not happening. And why this is happening? What is the problem? There is no x for -2 because f is not. Why there is a problem? Which property? Onto f is not onto. F is not onto, that is a problem because for -2, -3 or negative numbers there is no pre-image, and so we cannot define inverse function actually. So therefore even f is 1 since it is not onto, it is not possible to define inverse function. In first example even this f is onto, but f is not 1 so it is not possible to define inverse function, right? And that is what our second remark. So if f is from A to B and f inverse from A to B is an inverse function of f, then for any x in A, f of x is equal to y implies what is f inverse of y? That means what is f inverse of f of x? What it should be? X. That means f inverse composite f of x is x for every x in A. That means f inverse composite f is identity. Is it correct? We understand what I want to say. If f inverse is an inverse function of f, then f inverse composite f is an identity function, because if we apply f inverse on x, f of x is equal to y, then f inverse of y is x, but if inverse of y is just f inverse of f of x. That means f inverse composite f applied on x, acting on x, gives x. So f inverse composite f is identity. This last sentence is clear. Last sentence is clear. Yes.
Yes.
Okay. Also, for y belongs to second set B, what is f inverse of y is x, some element in domain. Then what is f of f inverse of y? Is f of x. And what should be f of x now? See, is it y? Because this is my second set, this is my first set, and I am just looking at y here, and if I am applying f inverse, but y is already, when I say I am applying f inverse on y, that means already y is a pre-image of something, right? So there is x, so that x goes to y. Already we know that y is pre-image of some x when I am defining inverse function. So, and therefore f inverse of y is x, then x is f of y. So y, and this is true. Therefore, f composite f inverse of y is equal to y for every y in what?
B.
B. And what is the conclusion? Is is what?
Identity.
On
B.
B. Right. So this is a very interesting thing we observed. So therefore, what is the moral of the story? What is the conclusion? Thus, what is our observation now? Thus, for f from A to B, f inverse from B to A is an inverse or G, whatever. So for f from A to B, the function G from B to A is inverse of f, right? So G is inverse function of f if what should happen? If and only if what happens? So G is inverse of f means what? G is inverse of f means what? G composite f of x, G or f inverse, because notation is whatever is notation. So f inverse. So G is the inverse of f if and only if what happens? G composite f of x is x for all x in A, and f composite G of y is equal to y for all y in B. Is it correct? What I have written is clear? Yes. Is it clear or any doubt? Yes. G is inverse of f. Then what we verified in the previous case, ki G composite f is identity, or G composite f inverse composite f. That means G is f inverse actually. I am denoting G by f inverse. Remember this. That means f inverse composite f or G composite f is identity, and f composite f inverse or f composite G is identity on B. Is this clear now?
Yes, sir.
Yes, sir.
Recall the yesterday's
Yes,
theorem.
sir.
If and only if. Recall the yesterday's theorem. G composite F is identity means what?
F must be 1 1 and G must be
1
on 2.
1 and G is on to, and by second F composite G is also identity. That means
G
G is
is
one
1
one
1,
and
F is on.
G is 1 1 and F is on 2. If and only if, this is equivalent to saying what? F is
F
1 1.
and G both are bijective.
Ah, F and G are both bijections, right? Now see this sequentially of what we did, and therefore as a conclusion what we have proved? As a conclusion, what proposition? We have actually proved it. What we have proved? What we have proved? What we have proved? If f is a function from A to B and g is a function from B to A, then G is inverse of F of F. Okay, suppose then G is inverse of F if and only if F is bijection. But F is bijection and there is no nothing like which set is first and which set is second, correct? So which set is first and which set is second? This is A, this is B, and I am saying that F is from A to B and G is from B to A. Suppose I start with G. G is from B to A and F is from A to. So this is equivalent to saying that this is if and only if G is a bijection. Right, and therefore F and G are inverses of each other if and only if they are bijections. Right, is it clear? That is what we discussed in the previous thing. And therefore what I can look at it in alternative way. So I can look at it in alternative way, that is inverse function of F from A to B. When is it possible to find inverse function? Exists if and only if. When it is possible to find inverse function? If and only if just
Function is bijective.
biject, right? Just recall the previous discussion. F is bijection, right? So if F is bijective, then certainly we can find inverse function, right? So this is what we discussed from previous discussion. Well, so now let us look at function F from 0 infinity to 0 1, and I am defining function f of x equal to x upon x plus 1. X upon x plus 1. Now question I would like to ask, can we find inverse function of f? Can we find inverse function of f? Yes. Can you find inverse function of f? So first of all, check whether it is on 1 on 2 bijective, right? So first of all, is f11 is f11. So let us check. How to check? Let x1 and x2 two elements in domain, right? So if f of x1 is equal to f of x2, right? So suppose images are same, that means x1 upon x1 plus 1 is equal to x2 upon x2 plus 1, because f of x1 is x1 upon x1 plus 1, f of x2 is x2 upon x2 plus 1, correct? Simplify this. Can we prove that x1 is equal to x2? That is a question. So x1 x2 plus x1, I am just cross multiplying and simplifying this. So x1 x2 plus x2, right? What does this imply?
x1 equals to x2.
X1 x2 product cancels. So what remains? X1 is equal to x2, and this is true for any x1 and x2. That means If images are same, then pre-images are also same. Or if pre-images are distinct, then images are also distinct. Therefore, f of x1 is equal to fx2 implies x1 is equal to x2. Or if two elements are distinct, then the images are also distinct. That is what we wanted to prove, right? And therefore f is 1, 1.
Sir,
Yes.
so this you have written that this function is from to 0, comma 1. What do we say? Closed brackets.
Close. Why close bracket? Okay.
It includes
F
the
of 0
codomain
is,
includes 1.
yeah. So f of 0 is codomain includes 1. Why? For for what value of x is it is 1?
For a 0. For 0, f of x equals to 1.
No. F of 0 is 0.
Oh, sorry, sir, my mistake.
0 should be included. That is fine. But should I include 1 also? Let us check.
No.
For 0 has pre-image, no problem. That is not an issue. Right? F of 0 is 0. So 0 in domain. So its image must be in codomain. That is fine. Okay. So f is 1, 1. That is clear. Now, is f onto? Is f onto? Okay, how to decide whether it is onto or not? So let us look at for y in 0 to 1. Let us choose y in 0 to 1. Not 1 is not included, remain 0 is included. Then can we find x in such that fx is equal to y, right? For if fx is equal to y, suppose image of some x is y, that means what? X upon 1 plus x is y. We don't know what is that x. We know y. We have fixed y from codomain and you want to produce. See, this is our domain up to infinity and 0 to 1, and I have selected y from codomain and I want to produce x here, but I don't know what is that x. I know y. I have selected y. I select y. I want to produce x. I know y. I don't know what is x. So I will solve this equation for x. Right? So x is equal to y plus xy, and I want to solve this for x. So x minus xy is equal to y. That means x into 1 minus y is equal to y. That means x is equal to y upon 1 minus y. So what is the pre-image of y, which is x, and what is x? And when it is possible to get pre-image of y as x, if
Not equals to 1.
y is not equal to 1, denominator will not vanish. That, and therefore 1 is not included, correct? 1 should not be included. Therefore, pre-image. So now if we apply f on x, which is y upon 1 minus y, right? So we have produced x, and from y we have produced x, and what is that x? Y upon 1 minus y, that x we have produced. Now is it the right candidate for pre-image? That means if we apply f on x, what we get, what we should get? What we should get, what we expect? Yes. How to verify that x which we have obtained is the right candidate? For example, okay, for example, if I choose 1 by 2, y is equal to 1 by 2 in codomain, then what is the pre-image x? Y upon 1 minus y. What is pre-image? Half upon 1 minus half. What is it? 1 by 4, right? And now the x which is a pre-image of y, now apply f on this x, that means f of 1 by 4. Does it gives us y which is 1 by 2? You check this. So what we expect, correct? So what we expect here now, if we have produced p-image of y which is x, and if we apply f on x, what we expect, what we should get? Yes, what we should get? What we should get? Y again? Right, so we select y and we produce a pre-image. Is it the right pre-image of y? That means if we apply f on x, we should get back y that we expect. Now let us check whether it is true. If we apply f on x, that means y upon 1 minus y, but by definition of f, what is f of x? X upon x plus 1, right? Therefore, what is f of this number? This number upon 1 plus this number, whatever is this number, right? And simplify this. So 1 minus y plus y divided by 1 minus y. You check the calculation, I'm making mistake, right? Divided by 1 upon 1 minus y, right? So what is it? Y upon 1 minus y into 1 minus y upon 1, and so it is y. So is it the right candidate for pre-image?
Yes, sir.
Right. And therefore for y in 0 to 1, its pre-image in 0 to infinity is what? X is equal to y upon 1 minus y, correct? And this is a well defined, because this pre-image always exists because y is not 1, right? What are the possible values of y? Less than 1, and therefore there is no problem, we can clearly find x, right? So this is true for every y in 0, 1. Can I say that f is onto?
Yes.
Right. So f is bijection, therefore f is bijection. F is bijection. Now the next question I would like to ask, what is inverse function? What is inverse function of f? And what is inverse function? F inverse is from, what is the domain of inverse function?
0 to 1.
0 to 1.
Infinity.
Right. What is the inverse function now, which we already calculated? What should be f inverse of y? And what is the idea? What is the inverse function? What is a y and what is a pre-image? Under f, this is f, and I want f inverse. So by definition of inverse function, if you want to define inverse function, what should be the image of y under inverse function? Just look at pre-image of y under f. And what is the pre-image of y under f?
Y
Pre-image of
upon
y upon 1 minus y.
1 minus.
Right. So f inverse is a inverse function y upon 1 minus y. It is from this 0, 1 to 0 to infinity. Right. Now next question I would like to ask is f inverse bijective. What is your answer immediately? From previous discussion, it is clear that if f is a bijective, right? If f is a bijective, its inverse function exists, and inverse function is also bijective. Correct? Now, what is f composite f inverse? What is f inverse composite f? Yes. What is f composite f inverse? You check this. F inverse composite f is identity on which set?
0 to 1.
Identity
0 to
on
1.
no
0
first.
to 1.
0 to
So this is identity on 0 to 1, and this is identity on 0 to infinity, because first we apply f in second case and then f inverse. In first case we apply f inverse and then, so, or this is identity function on 0, 1. This is identity function on 0 to infinity. Okay, so the whole idea is clear now. What do you mean by inverse function? Yes,
Yes, sir.
right. If I define function from r to minus 1 to 1, f of x is equal to x upon square root of x square plus 1. This function we have already discussed, right? Is f11. You should find answers of these questions. Is f on 2. We have already discussed this function in some previous session, correct? Is f bijective? Does f inverse from minus 1 to 1 exist? These are the questions. If yes, what is definition? Right? What is f composite f inverse and f inverse composite f? All the questions are clear? Have you understood these questions?
Yes, sir.
yes, sir.
Right. So the idea of inverse function is clear. Now I will give you one more example. Can you find a bijective function f from interval 0, 1 to interval AB? Can you find? Answer is
Yes,
yes.
sir.
Yes. Why?
Yes.
Because we already discussed that from any interval to any other interval, you can always find a bijective function, and all of you know the method how to find. Second question, you find many, there are many other ways. So if f from 0, 1 to AB defined by, suppose I define a function by f of x is equal to a times 1 minus x plus b times x, right? Then is f bijective? First thing, if S, what is f inverse from AB to 0, 1? Find the inverse function. And what is f inverse of a plus b by 2? Where is this point? So this is interval AB, and this is in between a plus b by 2 mean. What is the inverse image under f? Can you produce? Right? What is f inverse of? Now a plus so what is f inverse of a plus b minus a by 3 is okay. The question I would like to ask, a plus b minus a by 3, is it in the codomain? Is it in the codomain? A plus b minus a divided by 3, is it inside AB? Is it inside AB? What is your guess? And what is a simple observation? Right, what is a simple observation? A. And what is b minus a? B minus a is this distance, length. And in a, and what is b minus a divided by 3? 1/3 of this distance. Right, 1/3 of this distance. And if in a I add 1/3 of this distance, where is that point? Here. A plus b minus a divided by 3. So total distance is b minus a, and I am adding 1/3 of that distance. So certainly in A, if I add 1/3 of distance between A and B, the point remains less than B, and it is greater than A. That is a simple observation I can see, and therefore you can also check that A less than A plus b minus a by 3 less than B, or less equal, you can say. That means this number is inside AB. That is fine. But find inverse image of this number, particular element under this function. So now this question is clear. Question is clear. Check that f is a bijective function. If S, find inverse function. Find inverse image of a plus b by 2. This is a particular element in interval AB. Find inverse image. Question is clear or not? Any doubt? Is there any doubt? Yes. So no doubts. Okay, so I think our time is over, so we should stop here.